In this video, I will solve chemistry paper 4 alternative to practical, October-November 2022, paper 4-2. Let's start. Three colored gases A, B and C have properties shown. A is more denser than air, soluble in water. B is more denser than air, insoluble. C is less denser than air, soluble. Some sets of operators P, Q and R used to collect gases are shown. State which set of operators P, Q and R is most suitable to collect gas A. Gas A is more denser than air and soluble in water. So, this is the downward delivery with upward displacement of air. So, this is the most denser than air and soluble in water. So, the gases which are soluble in water always collected without water. So, this is apparatus P. R is used to collect gas B. R is used to collect gas B. R is should be insoluble in water and less denser than air. So, insoluble in water and more denser than air. So, this is B is more denser than air. State Q is not used to collect gas B. Q is not collect because this is insoluble in water and Q is less denser but soluble in water. So, that is why Q is not suitable. State why R is more suitable than P to collect gas B. State P, it would not be P, it would not be possible it would not be possible to tell the gas jar was full. State why R is not used to collect gas C. C is soluble in water. So, C is soluble in water. So, that is why R is not used to collect gas C. Question number 2. Student electrolyzes two aqueous solution using the apparatus shown. Name the apparatus E. Beaker. Complete the table. Iodine, observation brown liquid. Oxygen, bubbles of colorless gas. Hydrogen, bubbles of colorless gas. And dilute sulfuric acid is name of product at negative electrode. hydrogen, and H2SO4 hydrogen. Describe the test used to identify oxygen gas. Take glowing splint, near the gas jar. Observation: oxygen gas. Relight the. Please write down the name along with the observation. Relight the glowing splint. The equation for the reaction of magnesium with dilute hydrochloric acid is shown. A student investigates the rate of this reaction. Magnesium reacts with HCl to form magnesium chloride. A student investigates the rate of this reaction at 3 different temperatures. Conical flask, dilute hydrochloric acid, magnesium, and the gas syringe. In each experiment, student adds dilute hydrochloric acid to magnesium. The volume of hydrogen in apparatus F is recorded after 30 seconds. Name the apparatus F. This is gas syringe. Name a piece of apparatus that the student could use to keep the temperature of the conical flask and its contents constant. Thermostatically controlled water bath. Hydrogen gas is product of the reaction. Describe the test used to identify hydrogen gas. Take lighted splint in the gas jar. Hydrogen produces pops flame with lighted splint. The student uses the measurement of volume gas as time increases to determine the rate of reaction. State a different measurement that the student could make as time increases to determine the rate of reaction. State the different measurement that student should make as time increases, determine the rate of the reaction. Mass of flask, and content of the flask. In each of 3 experiments, the content of the flask are at different temperatures. All other variables are kept constant at different temperatures. 3 experiments are labeled X, Y, Z. So temperature X 20 degrees centigrade, Y 40 degrees centigrade, 60 degrees centigrade. The hydrochloric acid is in excess in each of 3 experiments. A catalyst is not used. Identify 2 variables that are kept constant in this reaction. Different temperature, all other variables are kept constant. So and hydrochloric acid is in excess. Concentration of the acid, mass of magnesium. Z by X. This is Z at 60 degrees centigrade. This is Y at 40 degrees centigrade, and this is the X at 20 degrees centigrade. Describe how the graph is used to decide which experiment has the greatest rate. How the graph is used to decide which experiment has the greatest rate. Z. Steeper the graph, fastest the rate of reaction. Steepest the graph, steep, fastest the rate of reaction. Write the letter in each box on the graph. Done. Describe how the graph shows that the reaction stops. Describe how the graph shows that the reaction stops. When the graph become parallel to x-axis. So at this point, so when the level of same level, and that this horizontal line represent the graph reaction is over. Explain why the reaction stops. The magnesium is used up because hydrochloric acid is in excess, so magnesium is limiting reactant. So when the limiting reactant is used up, reaction is over. A student is provided with two labeled bottles A and B and supply of water. One of the bottle contains 1 gram of solid potassium chloride, other bottle 1 gram of calcium chloride. When potassium chloride dissolves in water, change is endothermic. When calcium chloride dissolves in water, the change is exothermic. Plan experiment based on dissolving the solids in water to decide which compound is in each bottle. Calcium chloride. Plan experiment based on dissolving which compound is in each bottle. Which compound produces the greatest heat change per gram of the solid. Your plan may use any of the apparatus normally found in the chemistry laboratory but no other chemicals. Your plan must state all the measurements you need to make. Your plan must use the same experimental procedure for each solid. Weigh the solid one gram. Weigh the 1 gram of both solids of both solids with electronic balance. Add the solid A in beaker along with thermometer and then dissolve the solid A in water with glass rod and note the initial and final temperature of the solution mixture. Repeat the above experiment with solid B by using the same method. Sorry, in fixed volume of the liquid, sorry, in dissolved solid A in fixed volume of water with glass. Okay, by using the same method and measure the note the initial and final temperature. The beaker which in which temperature rises is calcium chloride, while the beaker which contain which has temperature fall is potassium chloride. The beaker which shows largest temperature change and then indicate the greatest heat change. Next question. Solution K is dilute sulfuric acid. A student determined the concentration of solution K using a method that involves titration. The student measures 20 centimeter cube of solution K using pipette. The student makes up the solution to 250 centimeter cube with distilled water. This is solution L. K is dilute sulfuric acid. 20 centimeter cube of solution K. The student makes up this solution. 250 centimeter cube have 20 centimeter cube, then 250 centimeter cube volumetric flask, and make up the solution till 215. Fill it with 2 distilled water. This is solution L. Now this is solution L. The student makes up the solution 250 with distilled water. This is solution L, which has sulfuric acid. Name another piece of apparatus that could be used instead of pipette to accurately measure the 20 centimeter cube of the solution K. This is solution, this is burette. Name the container in which solution L is made. Volumetric flask. A pipette is used to transfer 25 centimeter cube of solution L into a container. Name the other piece of apparatus. Pipette. Name the other piece of apparatus that is used with the pipette filler. The student adds 3 drops of methyl orange of solution L in conical flask and then place the flask on the white tile. The student fills the burette with a 0. Potassium hydroxide, 100 mole per dm cube potassium hydroxide. The KOH is added to the flask until there is a color change. State which liquid should be used to wash out the burette before filling the burette with potassium hydroxide. This is the solution is aqueous potassium hydroxide. Explain why the conical flask is placed on white tiles to observe the color change. State the color change of the methyl orange indicator at the end point. the color change from red to orange. The student does 3 titration. The diagram shows below shows parts of the burette with the liquid both at the beginning and at the end of each titration. Final burette reading is 24.2 and initial is 0.0. Second 46.5 and 25.2, 32.7 and 11.2. So by subtracting, this is 24.2, this is 21.3, it's 21.5, 21.24.2, 21.3 and 21.5. 21.3 plus 21.5 divided by 2, the answer is 21 point, the average is 21.4. So this is 21.4. Calculate the number of moles of potassium hydroxide in average volume. This is concentration into volume in centimeter cube divided by 1000. So 0.100 is the mole per dm cube into 21.4 over 1000, because volume in centimeter cube over here, so we have concentration. To equalize the unit, it is divided by 1000. So the answer is 0.0024214. The equation for the reaction of potassium hydroxide with sulfuric acid is shown. Use this equation to calculate the number of moles of H2SO4 in 25 centimeter cube of solution L. 2:1 and 0.00214 ratio X. Potassium hydroxide mole is 2 and sulfuric acid 1. So there is 2:1 ratio. We have mole of potassium hydroxide. So by using cross multiply, we can calculate mole of sulfuric acid. So this is 0.00107. So calculate the number of moles of H2SO4 in 250 centimeter cube of solution L. 25 centimeter cube has mole 0.00107. So moles of in 250 centimeter cube ratios X. This is mole ratio volume ratio mole. So by cross multiply, we have 0.0107. Reduce the number of moles of sulfuric acid in 20 centimeter cube of solution K. Calculate, reduce the number of moles of sulfuric acid in 20 reduce the moles of. So this is again 0.0107, because 20 centimeter cube is used. 20 centimeter cube over here. So 20 centimeter cube of solution K using pipette. So out of these we have 25 centimeter cube. So in 25 centimeter cube, this is 0.0107. So in 20 centimeter cube it is 0.0107. So calculate the concentration of solution K in mole per dm cube. Concentration is equal to mole over volume into in centimeter cube multiplied by 1000. So mole is equal to 0.0107 divided by 20 into 1000. So this is equal to 0.535. A different student does the same experiment using 30 drops of methyl orange instead of 3 drops of methyl orange. Methyl orange is acidic state if the average titration volume of KOH is smaller, larger, or unchanged when 30 drops of methyl orange are used. Larger as because the methyl orange adds more acid to the conical flask. Therefore, larger volume of KOH is required to neutralize. A student is provided with aqueous copper 2 chloride, aqueous zinc sulfate, and an aqueous solution labeled X. The student tests the 3 solutions by adding each reagent shown in the table: aqueous sodium hydroxide, blue precipitate, zinc sulfate, white precipitate, blue precipitate insoluble, remain insoluble, white precipitate dissolves, aqueous ammonia, blue precipitate, deep blue solution in excess of ammonia, white precipitate, dissolves, aqueous silver nitrate and dilute nitric acid. So this is chloridine. So this is test of chloridine, white precipitate of silver chloride. And this is sulfatine, no change. Aqueous barium nitrate and dilute sulfide nitric acid. This is test of sulfate ion. Over here no change, because in this compound chloride ions are present. So in compound zinc sulfate is present, so sulfate ions are present. So that's why white precipitate of barium nitrate. No change. X has no neither chlorine, neither nitrate ion, sulfate ion, or nor chloride ion. X is green precipitate, precipitate remains, green precipitate, precipitate remains, yellow precipitate with nitric acid, silver nitrate, and dilute yellow precipitate. Iodide ion. It means this is iron 2, this is iron 2, and this is iron 2, iron 2 ions. So if yellow precipitate, it means iodide ions. Then X contain iron 2 ion and iodide ions. When alcohol burns, they release heat. Question number 7. When alcohols burn, they release heat. A student uses the apparatus shown to investigate the amount of heat released in 5 different alcohol burns. The student determines the temperature rise 200 centimeter cube of water when an alcohol burns. The student repeats the experiment using the same amount of each alcohol. Number of carbon atoms in one alcohol, temperature rise. So this is the temperature rise, and these are the number of carbon atom. I have drawn earlier this graph to save the time. Plot the result on the graph, circle the anomalous point on the grid. So this is 2 carbon, this is 3, this is 3, this is 4, this is 5, this is 6, and this is temperature change at 7. Circle the anomalous point, draw a straight line of best fit, extend the line of best fit on your graph. Done. Use the extended line to deduce the expected temperature rise at 7. So this is 96 degrees centigrade. The initial temperature of the water is 15 degrees centigrade. Explain why this means it is not possible for the student to obtain temperature rise in B1. Explain why this means it is not at 15 degrees centigrade. At 15 degrees. Initial temperature of the water is 15 degrees centigrade. This means it is not possible for the student to obtain the temperature rise in B1 as water boils at 100 degrees centigrade. Suggest one change that can be made to the experiment that would make it possible to obtain the temperature rise in B1. Use ice or use water equals to or below 4 degrees centigrade. Suggest one change that can be made to experiment that would make it possible to obtain the temperature rise in B1. Use ice or use water equal to or below 4 degrees centigrade. This is end of the kitchen. This is all about this paper. Hopefully you like it. So if you like this video, if you understand, so subscribe the channel and like the video.